Assalamualaikum. So today we are presenting our project which is temperature sensor. So my name is Mohd Shukri and this is my friend. Uh, the first one is Aliff Irvine. Say hi.
Hi.
So the next is Mohamad Hazree Ikram. Say hi.
Hello, mate.
Okay. The next one is Mohamad Faisal.
Hello.
So the first presenting will be Mohamad Faisal first. So yeah.
Okay, thank you, Shukri. So I'm going to be presenting the flowchart of this project, which is temperature sensor. So as you can see from the slide, this is our flowchart of the temperature sensor. First of all, we can see here the start where we can where the temperature sensor will be checking the temperature on every minute, and after that the user can push the button, or there will be overheating environment in that rooms. So the system will read the input, and then uh, if the user push the button and there is an abnormal temperature in the room, the red LED will be blinking, and then there will be alarm. But if there is no if if the user didn't push the button, the temperature will detect it, will check it auto. So this sensor can be used manually or by automatic. And if the temperature sensing an overheat, the red LED will be blinking and be turned on, and it will alarm the user. But if there is nothing, there is no abnormal temperature, which means the temperature is normal, the red LED will not be blinking and there will be no alarm set. So that's all from the flowchart. Next presenter will be Hazree Ikram. Hazree Ikram, take it away.
Thank you, Faisal. So today I'm going to talk about our coding, which is temperature sensor coding. So the input and the output in the module must be declared. The module name is overheat. As you can see, the input is clock reset overheat underscore in push button in, and while output is overheat out. All input and output was declared as 1 bit. After the module was declared, another output register was declared to be used in always statement. Normally, each design is synchronized with a general clock, so the always statement can be used for that. It is compulsory to declare the output design with the red command, register command. Register is a memory element, but for practical purpose, a Verilog signal or identifier need to be declared as red register when used on the left hand side of the equation inside a behavioral Verilog statement that is used in an initial or always statement. Inside the always statement part, we must start with the command begin and close by end. Why? Because the design between begin and end is considered inside the same block. The command red is used in the always statement. The reset signal called RST is synchronized with the system clock that is affected only at active edge of the clock. Finally, to the module or the coding must be ended by using command end module. So I'm going to give Aliff to continue the presentation.
Alright. Thank you, Haji Ikram. Okay. For the next process is to create the test bench module. The test bench is a built-in self-test for simulation purpose only. This test bench is very useful to verify that the design is correct as the desired output or not as designed. There are 5 things that we need to know for test bench. First is time scale and module declaration. The time scale can be set to equal to the design module, such as that we use is time scale 1ns and 1ns 1ps. By default, the module can be named as test bench. The next one is input or output declaration. The input and the output used could be the same as the design using the same number or bit used. However, the input must be replaced as wire and output as red. The third one is insert unit under test or UUT. The module name of the file is to be tested is called, for example, shift rec 16 UUT, and the input output used for the UUT module is renamed with the dot operator followed by the input output declared in the testbed module for synthesizable design. That like the dot that we use in our UUT in the testbeds. The next one is the to initialize the input and simulation end time. This initialization process set the starting value for all input use and the value of when the simulation is used to be stopped. Like we use in our coding, like hashtag 10 clock, like that. Then the last one is clock generator. This part is to create the clocking function for the purpose of synchronizing the design, either by positive S trigger or negative S trigger. There could also be an instance where the programmer wish to employ both trigger depending on the function. Like we declare in the always test bench, always hashtag 10 clock, like that. And the next one, I will presenting about the output that we get. This is the output that we get from the test bench. Using the simulation, we verify this waveform from the test bench. The waveform are correlation between input and output are displayed. The programmer also need to check whether the output are as expected, and our output is what we expected to get. That's all from me. The next one, I will give it to Mohamad Faisal. Thank you.
Okay, thank you, Aliff. So I will be presenting the pin allocation. Okay, pin allocation is the process that needs to be of concern should the programmer want to test their design onto the evaluation development board. This can be found at implementation or user constraints or floor plan area. Different boards, I'm sorry, different boards has its user constraint file, or we call it as UFC, to map the inputs to outputs. The programmer needs to select the pin. As you can see right here, this design was from floor plan, and we get the output from this floor plan, which is the port clock. The location is AA3, the overheat in at the AB2, overheat out at the AA4, push button in at AB3, and then reset as UB. Okay, so right now I will be handing Hazree Ikram to further our presentation.
Thank you. So after output, testbed and pin allocation, this is our design implementation. The black one is from RTL, which is RTL schematic, and the white one is a floor plan. The design can be implemented onto the FGPA evaluation development board. Under the implementation view, the programmer can select view RTL schematic to see the connection of a conventional design using Z-links. So that's all for the design implementation. I'm going to give it to Shukri to finish our presentation.
Thank you, Hazree Ikram, for the expanding the project. So after all, we are collecting questions that frequently asked by people. So the first question is, what is the difference between CISO and SIPO? So basically, CISO is data shifted serially in and out of the register one bit at a time in either a left or right direction under clock control. While SIPO is the register is loaded with serial data, one bit at a time we store data being available at the output and parallel form. Okay, the next question is, what is Verilog? So Verilog is an HDL used to model electronic system, while VHDL is an HDL used in electronic design automation to describe digital and mixed signal systems such as field programmable, gates array, and integrated circuits. So the third question is, what is RTL schematic? RTL schematic show representation of the pre-op optimized design in terms of generic symbols such as adders, multipliers, counters, AND gates, and OR gates that are independent of targeted Zilling device. Next question. What is the wire and rack in Verilog codes? So we use wire when the output of a logic element is connected to an output of another logic elements, while rack is a variable in Verilog which is used in procedural assignment statements such as sensitivity list within an always block. It denotes register. So the last question, what are temperature sensor used for? So a temperature sensor is an electronic device that measures the temperature of its environment and converts into data in, then converts the input data into electronic data to records, monitor or signal temperature change. So that's all from us. Thank you.